So by this point we should have already covered the naive models and the moving average and the weighted moving average, which are basically constant models, that meaning that they are capable of generating a constant forecast for the future. And now we're going to cover what we call the single exponential smoothing, which is the most popular model within the exponential realm and the simplest one. So this model again is also constant, and it's used only when you know that you don't have a trend and you don't have seasonality, right? And the stability of the model will depend on a single parameter that's called alpha. So now don't you get worried, because we're going to see some formula here, but we're going to review together, so don't get desperate. So with the formula above, we look at different terms. First, we have t plus something, t plus 1 for example, right? And let's say t is 10, so we're looking at the first one. So what this formula means is that in order to get 11, you're going to use the forecast and you're going to multiply that by 1 minus alpha. Alpha being a parameter that goes from 0 to 1 and is what we call the smoothing. So we multiply that and then we add alpha times the actual value of period number 10. Okay, and different at this graph, you can see that when alpha is constant in here, we're looking here is the weights. Basically, what the exponential smoothing is doing is assigning weights. It's like a moving average. It's like a weighted moving average, but it's assigning weights to the different periods of history for that same data point. For example, data point 11, you are weighing data point 10 with a weight of alpha, and that you're also weighing data point 9 with a different weight, and so on and so on and so on until the first data value that you have. And the way weights are assigned is that they decrease as you go further in time. So the last values are more important, or have more weight for the forecast than the original values. And this can be tweaked with the alpha parameter. So if you have a very low alpha, what this is saying, this is calling out the weights of the different data points that came before data point t, which is in this case the one that we're trying to forecast, right? As you can see, they decrease as you get further in time, but as alpha goes down, and this is alpha 0.1, it becomes more constant. And as alpha goes up, you start paying attention even more to the last value and even less to the previous values. Okay, all of these models that we're going to see from here in the exponential family will have this type of behavior, in which you have a smoothing parameter, in this case is alpha, that is going to smooth history at some point in order to generate the forecast. In this case, it's just the level, because we are throwing in a constant forecast. And another thing that all of these models will have is what we call an initialization. Basically, when you are trying to generate the forecast for the first value of history, you don't have a previous historical value. So you need to come up with some way to start this forecasting process. And basically the initialization is very simple in here. It's just copying the actual value for value point number 1. In the next video, we're gonna dig into Excel so that we can show you how this model can be done in Excel. It's very simple. We're gonna see it in the next video.